My name is Philip Mwago. I am a technical product owner at Medic, and I'm part of the team that has been working on improving our dashboards. So I'll be answering the question why before we get into the how. So from an overview perspective, so we have the CHT basically, it is a tool that collects data from community health workers, and this data needs to be processed and visualized on a dashboard like you see on the sample dashboard that has about 3 widgets here. So this data is streamed from the database that is CouchDB all the way to Postgres, and then it appears on Superset or Clipfolio or Metabase or whatever data tool that you'd like to use in terms of visualization. So there are a number of ways of streaming this data. I think two in our cases. So we have Couch2PG and CHT Sync, which I'll be talking about today. Yeah. So the question on why CHT Sync is how we came to CHT Sync is we realized that some of our dashboards need to be are out of date. We're using the old configuration, so we have CHT Sync, and this solution basically has a number of technologies, as you can see there. So we have CouchDB, that's on the icon on the extreme left. That's my left. And yeah, so it goes all the way to Postgres. Then we have some modeling of the data there, and it appears on whatever visualization tool you have. So for us, we have the one you normally use is Superset. That's the reason you can see the Superset logo there. And yeah, so basically it's just a way of transforming this data from CouchDB all the way to Superset, and it needs to be up to date. Sometimes when you have like a lot of data, or you've been running projects over a long period of time, there's an issue with synchronization, and some dashboards may be out of date, and this is solved by having CHT Sync. So just talk about some of the technical stuff. So here on the right, you can see what's basically under the hood. For CHT Sync, it's just there's no UI on this. What you can do if you need any sort of UI, or just like do some monitoring, which Tom will talk about later. So we have Couch2PG, Postgres, DBT that models the data, and then the data visualization tool. So the advantage of this is it becomes real time. So what we did here was, say for example, when you see Couch2PG, there's that we had a different version of Couch2PG. We enhanced it to suit this need, since we already know the issues we have with Couch2PG, and we're already experts in it. So this streams data from CouchDB and updates Postgres, and then we use this some of these predefined DBT models to process the data that is now sent all the way to a browser for now visualization. For this part, if you need to see what's going on under the hood, probably need some form of monitoring. So in terms of where we are coming from, that's Couch2PG, and now moving to CHT Sync. They define how they're implemented. So how data flows from CouchDB to Postgres and then to the dashboard. So that's where the difference is. And for CHT Sync, which we'll be talking about today, which is our focus today, is an enhancement in terms of it's an enhanced feature that allows our dashboards to be a little bit more accurate and more reliable, which means they're more scalable. So ideally, what we did was just separate the syncing process of data from transformation. So now DBT comes in CHT pipeline and now handles the transformation of this data. And then this migration requires DBT models that in CHT pipeline, then that's a repo, as opposed to what we had in Couch2PG, that's some SQL queries, views and tables. So for some of the technical consideration, the ones you have include the container, what container technology you'll be using. That could be Docker, could be Kubernetes, some environment variables there, and also the YAML file. And like I mentioned, you are at liberty to choose whichever data visualization tool you'd like. This could include Clipfolio, Superset, or Power BI, and whatever it is that could work for you. There is no limit to that, as long as you're able to connect your your data visualization to Postgres. Yeah, that's it on my end. Yeah, I think I'll invite Tom to start up with the technical showcase.
Great, thanks, Phil. So my name is Tom Weir. I'm a software developer at Smitic, working on CHT Sync based out of Kampala, Uganda. And what I'm going to do today is a demo of setting up CHT Sync, including building the DBT models and doing a deployment with Docker Compose, and using a demo CHT instance that has been set up to look like it's been an existing deployment using Couch2PG. So if you don't know what Couch2PG is or haven't been using it, the steps will be very similar as if starting from scratch, but I think most people who are interested in CHT Sync already have an existing Couch2PG setup running. So we're going to use that to build the DBT models. So let me share my screen here. Okay, so there's some links to the documentation in these slides. Mostly what I'm going to be doing actually is just following these documentations. So we have one for migrating from Couch2PG to CHT Sync, one for general deployment of CHT Sync with Docker, and one for setting up the DBT models. So I have a CHT Sync instance, a CHT instance here. Just having a little trouble with the screen sharing. Okay, so I have a CHT instance here with some test data. It has the default configuration from the CHT core repository, but I've changed the pregnancy registration form a little bit and the contact hierarchy a little bit to make it more representative. So the contact hierarchy is meant to be representative of an actual CHT instance. We have districts representing sort of a large region, and then health centers representing a CHW area, a smaller region that a CHW is assigned to. And then you have households and patients underneath those households. So this CHT instance has already been set up with a Couch2PG thing and a database that's running locally on my computer. So I've already run Couch2PG to sync the data from that test instance to my local database here. We have this root table here, v1.couchdb, that contains the unformatted JSON data from the CHT instance. And I've also created some materialized views to simulate the types of things that are typically created in a Couch2PG setup. So we have what's showing on the screen here is pregnancy form view. This is a materialized view that's selecting from a typical pregnancy form. It's reading from this source table, filtering where type, data record, and form is pregnancy. And then in this middle section here, it's pulling fields out of that JSON structure and then moving them into columns. And we also have a dashboard materialized view that is selecting from that pregnancy form, joining to other types of contacts, households, CHWs, health centers and districts, and aggregating the number of those forms submitted where danger signs were yes. This is supposed to just represent a typical materialized view that would be used in a dashboard. And then finally, we have another materialized view for households. This is selecting instead on contacts. So selecting again from this source table, CouchDB, where the contact type is household, and then again pulling out some fields from that JSON structure into columns in this materialized view. So these are the things that we need to convert to DBT models for CHT sync. So as Phil mentioned, the way CHT sync works is it's just like Couch to PG, copies data from Couch into Postgres, and then it uses DBT to copy data from the source table, where it's just in a unformatted JSON, into proper tables in Postgres. And one thing that it provides is some what we call base models, which are tables and transformations that are common to all CHT applications. But not all data is common to all CHT applications. There are things that each CHT application does differently, forms and contact hierarchies. And so for those, we need another DBT project, and each CHT application needs to develop its own DBT models. So let's look at how that is done here. So I have DBT installed locally on this computer. So I'm going to start a project with DBT init. Just call it CHT sync demo. I already have one, so let's actually just call it CHT sync demo 2. Okay, it's going to ask for some options here. We want to use Postgres. There's different ways to do development for these DBT models. Usually you want to do development locally before publishing them to GitHub or running them on a production server. So what I'm doing now is just running DBT locally. There's also a Dockerized version. But because I'm running this locally and because my database is local as well, I'm going to connect this DBT instance to that local database. Now, you may also, in real-world scenarios, want to have a separate database for testing. This is basically going to use the same database that the CHT instance is using.
Tom, just to ask if it is easier to increase the font size a little bit. So that's okay.
I'm just entering the credentials here. DB name and a schema name. We'll just call it V1. Okay. Okay, so let's run dbt debug to make sure that it's connected successfully. And it looks like it is. So we do need to set some environment variables. The table that dbt will use, which we're calling CouchDB. This is the source table again. The schema, which we said is v1. And I think it will ask also for the database name. So if you use the Dockerized version, these will just be set from an in file, but because I'm running locally, I have to set these here. So we have dbt now running and connected to our local database. The first thing that we want to do is get it to run those base models that are common to all CHT applications. And the way that we do that is by setting the package as a dependency. So dbt has this feature where you can include other dbt projects as dependencies. And we have published the base models as a dbt package. And now we want to include that package in this local dbt project that we've just created. So I'm going to edit file packages.yaml here. So I just copied this package definition from another window. But basically, this is telling dbt that we want to include this package at this URL, which is the base pipeline, base models, with this revision here. So it's important to include the revision so that if there's any changes to the base model, the downstream projects don't break, and you can test the changes to the base models and deploy them when you're sure that there are no breaking changes there and that there's nothing in the downstream models that depend on things that have changed before you actually deploy. So we actually want this version here, 1.3.1. Okay, so now I'm going to run dbt deps to install that. Okay, and so now I'm going to run dbt run. So this CHT sync will usually do this for you. But since we're developing locally, I'm just going to run it from the command line. What this will do now is this will, reading from the table specified in these environment variables, it's going to create those base models and populate them with the data that was already added from CouchDB. Okay, so this is pretty much what we expect here. This is the output of dbt showing that it's created these base models. And if we go back to the database, I have this connection to my local database here. We should be able to see those models. So the next step is going to be to start creating the dbt models that are specific to this CHT application. And they're going to fall into 2 or 3 main categories. So the first one is custom forms. So there is this table in the base models called data record, and this contains all form submissions and some metadata about the forms. but it doesn't have any of the fields of the forms themselves, and all the different types of forms are lumped together into this one table. So what we need to do is for each form that we want to analyze and include in dashboards, we need to create a DBT model for it that is going to create a table that is specific to that form. So because that's a very common thing, and there's a lot of boilerplate around that, one thing that the base models provides is a DBT macro that will create that automatically. So just to save time with typing, I've already created these models, and I'm just going to copy them into this DBT project. Okay, so this shows how to migrate from this pregnancy form view, materialized view, to a DBT model using the CHT form DBT macro. You can also just create a regular DBT model if you want, but because there is some boilerplate, and because all of the form tables are doing pretty much the same thing, we recommend that you use the macro that we provide. So in this materialized view, what I've done is pretty much just copied all of the fields from this materialized view into this DBT macro. So this at the bottom here is where it's called CHT form model. The arguments it takes are the name of the form, the columns that are specific to this form, and that we want to copy from the CouchDB JSON document into columns. And then if there are any indexes on those columns, to include those as well. So this section, middle section here, set form columns, is pretty much just copied from the materialized view. The only things that are different are there are in the materialized view some metadata about the forms that is actually included in this macro by default. So that's things like reported by parent, patient ID, I think. And it's not shown here, but the report date. Okay, so now let's run DBT again and see if that model that we have just created works. First, I'm just going to copy the macros over. You wouldn't normally have to do this. Okay, so now there is a, you can't really see it here, but there's a new line in this output, v1.pregnancy, and that is the model that we've just created. So let's go back to the database and make sure that it's actually there. Okay. So it's a little cramped to see all of the stuff here, but we have the same fields there from this materialized view, and also the DBT model are now in the database, along with some of this metadata reported by parents, reported and reported by. So the next common thing that needs to be that needs to have DBT models created for it that's specific to CHT applications is contacts. So each CHT application can potentially create its own contact hierarchy, and in a very similar way to the forms. We also want to have those pulled out of the JSON into their own specific tables, and any fields that we want to index pulled out into columns. So because that's also very similar, we have a similar macro for that as well. So for contacts, we don't necessarily want to copy all contact types into their own tables. For higher level contacts or things that don't have their own fields, or any specific reason that they should be in their own table, there is in the base models a model called contact, and similar to data records, that contains metadata around contacts, when they were created, their parent type, that sort of thing. But all contact types are linked or merged together in this one table. And usually we want to have each contact type having its own table. So for this demo instance, there is a contact type household, CHW, and patient. So again, I'm just going to copy the models to the DBT project. Okay, and let's just look at one of those as well. So it's a very similar macro to the form models. Specify the contact type, any custom fields, can also specify indexes, although this model doesn't. And then the one thing that's different is this our second argument here, which is the parents. So in contact hierarchies, it's often very useful to have joins to parent tables, and to be able to access the columns from the parent tables as well. So for households, we're just joining to its direct parent health center. We look also at CHWs. It's more common that you may want actually joins to higher levels in the contact hierarchy to be able to do aggregations off of those. Okay, so let me run DBT again to make sure that these are created correctly. And yeah, so we have a couple new things here: CHW, household, and this one, patient person. So there is in the base models a model called v1.patient. It's not usually very useful In this case, and in, I think, most cases, it's more useful to define a custom patient model, which here we have just named patient person. Okay, so I think I'm out of time. There's a lot more we could go over, but yeah, I think looks like I'm about out of time. So I think maybe that's a good stopping point.
Tom, thank you for the presentation. I went through the online documentation. I was looking at the DBT macros. Is the documentation available? Because that's
Yes, so there's some examples and some documentation about the arguments in one of the documents. I'll put it in the chat, but it's called Building DBT Models.
I welcome Philip Oyer to share his experience.
Thank you very much, Niraj. So we had a use case of a project that we were calling the CDSA, basically meaning we were doing a decision making algorithm on the back end and the CHT applications on the front end. So we had 7 diseases. We had symptoms that matched to either true or false for each of the diseases. So a user had a list of symptoms from which they were selecting either they have them or not. If they're present, it's a yes. If they're absent, it's a no. And then a combination of the choices will make us conclude possible conditions, either malaria and rare diseases, malaria and malnutrition, pneumonia and typhoid, pneumonia and TB, malnutrition and pneumonia. So A, B, C, D were the symptoms, and we had a good number of them. The question is, where did we get the symptoms? So we did a bit of desk review and used some of the data that we collected earlier. We've been doing a lot of project in community health, and there's some data that we have built. So we use the data we've collected and also doing a bit of desk review to know which symptoms go with which disease. Our hierarchy was simplified because I think the last project we did, we had 7 levels. For this one, because it was just to do a proof of concept on the algorithm, we had the national office, we had the county, we had the link facilities from which we recruited clinicians. And this was done in 2 counties, Kilifi and Kisumu. So for each county, we had 2 facilities, and for each facility, we had 2 clinicians. And then, of course, there was the health facility administrators, and finally, the clinicians. All right, so we had 2 challenges. The first challenge was because the users were selecting a number of conditions. Now, some of those conditions required lab tests. So in case the clinicians had to send the patients to the lab, repeating the same lab tests for a number of diseases was a problem. Like in this case, if you select MRDT and SAT, so when the results come, you want to update for MRD separately and then for SAT separately. So that meant we had to repeat that. Now, our last configuration was CHT 3.16, and 3.16 did not support the repeat. So after consulting the community, we upgraded 4.10, and version 4.10 supported repeat logic, and our application ran very well. The other challenge we had was, of course, because we wanted to ensure that we can get up-to-date data. As Philip had said, that using Couch2PG, we are not getting up-to-date data. But for this project, because remember, we are doing a proof of concept, we wanted to get up-to-date data in terms of what has already come, so that we compare what the clinicians give as the diagnosis against what the system was giving as diagnosis. So the migration from CHT 3.16 to 4 and configuring CHT sync made it possible for us then to get both. We were able to take care of repeat, but above all, we were getting up-to-date data that allowed us to report to our funders as they needed the report. Thank you. So the challenge, as I said, one was the repeat group duplicates from CouchDB to Postgres. We realized after the implementing, we were getting a lot of repeat groups. So we implemented materialized views and the views, so that sorted the problem. Then now the challenge was the data, like by end of, we wanted data up to end of August, in September, up to end of September. But by the time we downloaded the data, we could only get data up to end of August. That means we were missing data for September. And because reports were being written on a weekly basis, that meant that we had to wait for a complete month cycle before we could be able to update. That is if you're using Couch2PD. But by moving to CHT Sync, because we are getting up-to-date data, so it was easier then to report as was required by the funders. Just like I think Tom had so we created a different schema. So we had the original schema for the Couch2PD, but we configured another schema for the CHT Sync, and that was basically we used for the implementation. Yeah, so the lessons we learned from this exercise, one is planning is very important. Like I think we made an assumption that it would have been easier to move from Couch2PD to CHT Sync. So planning early, especially the customizations. For us, as we already had data in the earlier version, so we had to migrate the database from version 3.16 to version 4. Before now, we could be able to configure the other workflows. So planning early makes things better. The number two, having a test and local instance for piloting. As I think Tom had shared the same, that it's easier to have a local instance where you test and confirm that everything works before you move to the production. Because if you do this on a production server, remember, we had already clinicians in the field. So any disruption on the app, it means the clinicians cannot be able to fill in data as the patients were coming to the facilities. The number three, community becomes a very good place for me always to get technical assistance. Anytime I get stuck, I go to the community and we'll always be able to get solutions. One of the great sessions have always been the virtual technical troubleshooting sessions. And I think Tom, Philip, and many of the colleagues here, Anthony has been great in organizing those sessions so that now we meet virtually and look at through. By the time we are done with the session, the solution is found, and this has always been great. Thank you.
Philip, how easy was it just to set up CHT Sync for you? How was the learning curve?
The learning curve, that's what I'm saying. I assumed that it will be an easy exercise, but when we started doing it, I realized it was not as easy as, because already we had an ongoing installation. I think it would have been easier if we were installing from scratch, but we had to migrate the data. So if you look at the documentation, it was a two-part process. One, first migrate, and then now do the installations of the DBT and the other aspects of the installation. So the learning curve was a bit stiff because we made an assumption. And that's why I'm sharing that it's always good to plan ahead, because maybe if we did better planning, our learning curve would have been shorter. Thank you.
Great. Thank you, Philip. You said about like migrating the data. Is it okay to share like how large the data was?
Okay, for this one, the data was not very large because remember, we're only using 2 facilities. In the past, we've had more, we are dealing with 2 counties, 4 facilities. But in the past, we've had larger installation. So the data was not much, but the only challenge was to ensure that we don't lose anything in the migration process.
Hi, Philip. Just curious if you use any data visualization tool on top of the pipeline you have, like Superset or anything else? And if yes, how easy was it for you to create dashboards?
Thank you, Adra. So for this kind of use case, we do not push the data to the dashboards, because remember, we are just doing a proof of concept. So you have a clinical decision-making algorithm behind the forms, and then the clinicians also make the prediction, and then you compare. But in the past, we would use Superset, and for us, we didn't have a problem with Superset. So we already went through the pipeline of pushing data to a dashboard. So I don't think that would have been a challenge even now, because we've done it before.
Great.
Thank you.
Thanks, Philip. Next, Edwin, would you like to unmute and ask your question?
Yeah, thank you, Niraj, and thank you, Philip. I also think partly my question has been answered, because I wanted to ask Philip how long now it takes for them to visualize that on their dashboards. And I think it was answered in the question that was asked before. Thank you.
We will be now talking about showcasing in production, and for this, Alex Combo will be showing us more about it.
My name is Alex. I'm part of the app development team at Medic, and I'm going to be taking you through what our experience has been, and also just showing a little bit of what the migration process looks like when you're taking on DBT in place of Couch2PG and the SQL queries as they were before. So one of the things we found when we embarked on working with CHT Sync, and especially now the DBT models, is that we brought in quite a lot of modularity to how we were writing the queries. Before, we'd have functions that would essentially pull data for related chunks of data. So imagine you are trying to build, let's say, some materialized views of some data for, say, NCDs. And here you want to pull things for, let's say, like diabetes and so forth. So before, in our implementation, we'd have one large functions, and at the point when it was running and trying to refresh it, it would be really, really slow. And it would take quite a bit of time for new data to come in before now the materialized views are refreshed. So with DBT models, what we found is that we could write very simple, sometimes even one line select statements, and that would be enough to create either a materialized view or table that we could then visualize on Superset. The second thing, and Tom alluded to this before, is there's quite a lot of statements whenever you're writing these queries that are repeated. So a lot of this was abstracted into macros that we could then just plug into any query that you write, and that would reduce quite a lot of the boilerplate that the developers were writing from before. The third thing is that unlike the previous development method, unlike the previous way of writing these queries, we found that with DBT, because of how it is structured, we could approach it from like your typical development perspective. So think in terms of having multiple developers working on the same code base. We could have tests, we could have different branches, we could have sandbox environments, and everyone will be able to advance their own work without interfering with each other. Also having version control and ensured that we could always check any issues that came into the system, and could always roll back to previous versions, and you could always have like a history of any changes that went into the master branch. And lastly, with the tests that we included, we found that a lot of the data integrity issues that we had from before, like nulls and sometimes, let's say, having zeros where you expect to have some numbers, uniqueness and foreign keys and some value constraints were caught even before the models themselves were pushed. Tom showed when he did that DBT run query, and you could see the models being built. At that step, if there was any issue, any data quality issue that went through, it will be flagged at that point, and the models will not be built. So this ensures that it's just kind of like the same way you would write your code, try to run your tests locally, see if it fails or if it breaks, and then you commit your code to GitHub. It would be exactly the same. So I found that it was a lot easier for us to work with a larger team, and given the amount of work that we needed to do, migrating all the queries from the old vanilla SQL to DBT, we could have at least 3 or 4 engineers all working at the same time, and everything went on smoothly. Something that we could not do before. So all this is not without its challenges. So one of the things we encountered, especially at the beginning, was there was an initial learning curve. Tom went through the showcase of how to set up DBT internally, or rather locally, and that itself is a bit of a learning curve. But even if you get now over that, there's some slight differences to how you write your queries from vanilla SQL. Something like reference functions for how you would refer to your tables, as opposed to just saying select from, and then you give like a table name. Usage of macros in place of repeated blocks of code. That was different from traditional SQL development. And for new devs who came in and started learning from DBT and who were not too familiar with SQL, they had quite a bit of challenge just understanding the structure of the macros, how to reference the tables, and just having also the common table expression patterns in some of the queries. But once they got over that, then it was smooth sailing from there. Second thing is on the local testing. So depending on how you set up your DBT environment, it would be somewhat difficult to test locally, and it would involve sometimes having to push your code to GitHub and then running DBT on your Docker instance separately and trying to now connect that to your commit and seeing if the models themselves will be built. That's an option if you don't set up DBT locally on your machine. And because of that process of having to commit and having to run the code on Docker to check if the models themselves will be built, meant that sometimes if you were to just write your query, before you can actually build it would take some bit of time. But once you get the hang of how the models would run, then it would be very easy for you to write models that would work at least by the first or second try. So the demo I'm going to show is just sort of like a repeat of what Tom had shown, but going a little bit deeper on trying to transform traditional SQL form into a DBT model and what that looks like, and also just going through the macros just a little bit deeper and just explaining what each one of them does. All right, so this is a very simple form for wash. So this is just a regular form. So you have your select statements. All this is pulled from the CouchDB, where the type is a data record, and then the form name is wash. So Tom had mentioned that we have this data record as sort of like a root table where all the forms are put there and they're not necessarily differentiated. You have to go pull that information out. So this is what I'd expect that anyone who's running any queries against the existing CHT Couch2PG queries would look something like this. So going on to what now a DBT model would look like, you can see that the structure changes slightly. So the first thing you notice is that we have this configuration block at the top here, which this first value here just tells us that we're creating a table here and not, we could also say this is a materialized view, and that would change this into a materialized view. But for the purposes of our demonstration here, this will be a table. We're also saying that we will have a unique key, which is now a UID as defined here, which on our alias. And then we're saying that whenever this schema changes, we want to append the new columns. There's this very last column added here for the save timestamp. What this does is that it just tells DBT that whenever it's pulling the new records, it checks against the last save timestamp and pulls any records that came after that. That now what gives CHT sync the edge and making it a little bit faster than before, where it doesn't have to rebuild the table or trying to find what the new records are. Then we've got now our indexes here, where we have our UID, and then we have our save timestamp, reported by, and reported by parent. Then you'd write your normal select statement as before. And now the key changes come at the point of now referencing your tables or your root tables. Like before, we would say something like v1.data record. But now in this instance, we will say now it's a reference and we just pass the name of the data record. And this now will be the same for any other place you'd be writing your DBT models where you need to reference the name of a specific table. And then now here we're just seeing where the name of the form is just, in this case, is the household flood status. Now, there's some things that will be repeated across regardless of whichever form you'll be writing. We've got this block that will exist every time. We've also got this section here for the data record. We're picking the UID, the timestamp, the reported, and this reported by and reported by parent. And also this final block where you're selecting from the data record. And then where you select, you're putting in the name of the form. So these bits have now been extracted and put into reusable macros. So in this macro here, we have now the first one where we've defined our data record columns, which are repeated. So we've got our UID, save timestamp, reported by, and reported by parent. This is the same as this one, this one, this one as defined. Then now we've got our indexes here. Again, we've got our UID, a save timestamp, reported by parent, and reported. Those ones, again, they appear here as well. And we've got the from block where we say here from data record, we do our joins on the CouchDB table, and then we say what the name of the form is, and we pass it here, and then we have our save timestamp as defined here at the bottom. So all these are now the different macros that have been predefined and you can reuse them. Then we have our macro builder, which just takes all those different macros that have been defined at the top and now sets them in the same order as defined here. We've got the config block, and then you've got your custom queries here. We've got our from, and then this last bit here. So this is sort of like the skeleton of what now pre-fills those whenever you're creating any new DBT models. So what does that look like now for our original wash form over here? So now we've got here where we don't have to define the config block because that is already set up by this CHT form model. We know that the name of the form we're picking is wash, so we pass that. These custom fields are the only thing that change from form to form. And that's where the most of the focus should be for any developer who's building any new DBT model. This is what you'll just be adding. So you can define any custom indexes that do not exist in the macros. And in our case here, we've got the has functional latrine as a new one. We've also got, yeah, that's the only one. Then we pass that here as form indexes. And then these custom fields are the ones that we have added here that are unique to our form in this case. Yes, so this would be the structure that you would use for any forms that you would create. Wash, pregnancy, immunization, under 5, over 5. It just depends on whatever fields you want to pick. So this just makes it a lot easier, and you don't have to do quite a lot of writing to build the forms as before. So this would be the structure for a lot of the forms that you would build on DBT. Thank you.
Yeah, so I'm going to share some resources here. Let's just put some links to the documentation that we have currently. So we have some on the doc site. Thomas shared some of that. These are forum posts, and you also shared a blog post. So yeah, if you want to read more on the code from Lorena there on how CHT Sync improved the reliability and timelines of the data in within CHT, you can look at our the Medic stories. We have a blog post on the same there. So I think that's it on my end.
Thank you, everyone.